Hey everyone, let's take a look at number 8 in section 10.1. We're going to use the appropriate limit laws and theorems to determine the limit of this sequence, which looks like the sequence, a general term is the difference of two radical expressions. Um, to evaluate this limit, I'm going to use a conjugate. If you remember, the conjugate of the square root of a minus the square root of b is just the square root of a plus the square root of b. And what do conjugates help us with? Well, uh, take a look at this expression here, the square root of a squared minus the square root of, the square root of a minus the square root of b times its conjugate. Well, multiplying by first, outer, inner, last, right? The first, the square root of a times the square root of a is just a. The outer is square root of a times the square root of b. There's the outer. The inner is negative the square root of b times the square root of a, or negative square root of a times square root of b. And the last is negative times positive negative square root of b squared is b. But look at the outer and inner terms. Notice they're just opposites, and so they combine to 0, and we're left with just a minus b. This is really just, in a sense, factoring the difference of squares, if you want to think of it about that way, because uh, the square of the square root of a is a, and the square of the square root of b is b. But at any rate, this is what I'm going to use in this case. Notice as n goes to infinity, the square root of n plus 9 is going to infinity, and the square root of n is going to infinity. Well, you have infinity minus infinity. Remember, that's not 0 necessarily. It could be 0, it could be infinity, it could be some other value. The way I'm going to do this is to think about this expression just as a fraction. All right, just writing it over 1. And now I'm going to multiply this fraction by 1 in the form of the conjugate of this numerator. In other words, I'm basically going to rationalize, if you will, the numerator. So you have this expression here, which doesn't change the value of the general term because this whole thing right here is equal to a grand total of 1. On the bottom, we'll just have 1 times all this stuff. So we'll have the radical expression down below. But now using what we talked about here, when we multiply these together, the first times first gives me just an n plus 9. The outer and inner will be opposites. They'll cancel to 0. And negative the square root of n times positive square root of n is negative n. Simplify up top. That just becomes 9. And now notice this. The denominator, as n goes to infinity, is infinity plus infinity, which is infinity. So the form of this limit is 9 over infinity, which is clearly going to 0. So in this case, infinity minus infinity is approaching 0, and the limit of this sequence is 0. Okay, I hope this helps.